Hi. Today's lecture is about Newton's law of motion, which is related to force. And force is related to the mass of an object and its acceleration. So F equals ma, where F stands for force, m stands for mass, and a stands for acceleration. Another type of force is the weight, which is related to mass and the gravitational acceleration. So W stands for weight equals mg, where m stands for mass and g stands for the acceleration due to gravity. So weight is a kind of force. Now let's look at some examples. The first one is the easiest one, which is a block being moved by a force. Here the question says, consider the figure as shown. Of course, this figure. If the mass is 10 kg and the force is 100 Newton, find the acceleration. Suppose the system is frictionless. So there is no friction in this system. Here it says F equals m times a. So F is given 100, m is given to be 10, and here is a. So a equals 100 divided by 10, which is 10 meters per second square. And the unit of acceleration is meters per second square. It's that simple. Another question is, as shown in the figure, which is this one, I've just circled, which consists of two blocks tied with a rope. So here the question says, consider the figure shown on the right-hand side. Find the acceleration. This is in part A, and in part B it says the tension in the rope. So in this problem, we're going to find the acceleration as well as the tension in the rope connecting the two blocks. Okay, let's look at the free body diagram of this system. Here is M1, which is 7 kg, and this one is M2, which is 5 kg, and they're connected by this rope. So the free body diagram for this one is this. For the first object is this one. Here is the applied force, and this one is the tension in the rope. The applied force is pulling the object forward to the right, and the tension is a resisting force in this case, which is preventing the block from moving to the right. And now, if the force is bigger than the tension in the rope, the body can move, otherwise it can't. Let's calculate the force and the tension and the acceleration. For example, for this system, for block number 1, we're going to get F, which is the driving force, minus T, the resisting force equals M1A. And now for the block number 2, we're gonna get T being equal to M2A. If we add the two equations, we're gonna get F minus T plus T. Minus T will cancel this T, and we're left with force being equal to M1A plus M2A, which is M1 plus M2, and A can be taken as common factor here in this case. So A equals F, the driving force, divided by the total mass, M1 plus M2. So A in this case is going to equal 120 Newton divided by 7 kg plus 5 kg, which is the summation of which is going to be 12. Therefore, A is going to equal 120 divided by 12 and is going to equal 10 meters per second square. And now we can find the tension in the rope, where T equals M2A and equals 5 times 10, which means T equals 50 Newton. Therefore, acceleration equals 10 meters per square second, and T and the rope equals 50 Newton. And since tension, which is a resisting force, is 50, which is less than the value of the force, which is 120, then the system is going to be in motion with certain amount of acceleration that was calculated to be